Right, Matrix, let's have a look at this example involving length of tangents from a point outside the circle to a circle. Now, what we've got here is determine the length of the tangent from minus 3, 1, from that point to where it meets the circle, and the circle is given by this equation. We want the length of t, the length of PA. We've got the point outside as minus 3, 1, and we want to be able to determine the length of that tangent. Now, the thing about this is you'll notice that I'm going to call that A there, but you'll notice that if we draw the radius, it's quite possible to get the length of the radius of this given circle, which we'll do in a moment. And there's the center we could also easily get. And if we can get the center and you then join A to C, or P to C, you remember the radius is perpendicular to the tangent. So we could use Pythagoras. We're going to get the length of the radius. We want to get the length of PC, and then it's easy to get the length of PA. But the question is, how do we get the center and the radius of our given circle? Well, there it is, and here it is here, and we're going to need to complete the square to be able to do that. So let's have a look. Let's rewrite that equation. We've got x squared minus 6x plus y squared plus 2y plus 6 is equal to 0, and let's complete the square to get the center. So the first thing, let's bring that positive 6 to the right side, and it becomes negative 6. Okay, complete the square here. X squared minus 6x plus half the coefficient of x all squared. We added it in, so don't forget to do it to the right. Plus the y squared plus 2y plus a half the coefficient of y all squared. So what do? We plonk those onto the right side as well. You could, of course, if you want to, have worked it out unlike what I'm doing here. Okay, so what does this come to? X squared minus 6x plus half of negative 6 is negative 3 squared is 9. Okay, plus y squared plus 2y. Half of 2 is 1. 1 squared is 1 is equal to negative 6 plus the 9 plus the 1. If you look at that, so if you added the 9 there, you put it on the right. Add the 1 on the left, put it on the right. So, what do we have? We've got x squared minus 6x plus 9 plus the y squared plus the 2y plus the 1 is 9 plus 1 is 10 minus 6 is, of course, 4, which is great. And then this factorizes, this x squared minus 6x plus 9 factorizes into x minus 3 squared, and this gives you y plus 1 squared is 4. Okay, so what is the center here? The center is 3 and negative 1. Remember, minus 3 becomes 3, positive 1, negative 1. And the radius squared is 4, so radius is 2. So there we go. So the center is 3, negative 1. So we've got the center is 3, negative 1. And the radius of the circle there, we can write it in here, is going to be 2. Now all we need to do, we've got that radius. If we can get the length of PC using the distance formula, we would have that length, and then the rest is very simple. So let's have a look. If we work out using the distance formula, let's have a look here. So we've got PC squared. Now let's just have a look at that carefully. PC squared, if we just go up here, PC squared, I'm going to do it over here and then we'll write it at the bottom. PC squared is what you're going to do is you're going to have to use the distance formula. So what we could do is we could say 3 minus negative 3 all squared. So it's that x minus that x value all squared. And then we've got plus, then we've got the negative 1 minus the 1 all squared. The negative 1 minus 1. So it's the difference between the x's squared, 3 minus negative 1 all squared, and then negative 1 minus 1 all squared. So what is that? That's going to, so if we rewrite that at the bottom here, we can see PC squared is going to be the 3 minus the negative 3 squared plus the negative 1 minus the 1 squared. So PC squared would be that 6 squared is 36 plus the 4, because that's negative 2 all squared is 4. So then PC squared is 40, and PC would be then the square root of 40 there. Okay, now if you have a look at this, let's just see PC squared. PC is the root of 40, so we've got this is the square root of 40. Now, all we've got to do is use Pythagoras to enable us to work out the length of the tangent there. So what I'm going to do is I'm going to just get myself some space here to work with that, and then we can easily do it. Okay, so we'll just clear that, give us a little bit of space, and then we can say no problem. We can then easily work out the length of the tangent. So how does this go? We can say that PA squared, that squared, plus the 2 squared is the hypotenuse squared. So PA squared is plus AC squared. Remember, this is AC squared, and that's PC squared there. Okay, and then of course it's easy to work it out, because then you say PA squared plus 4 is 40. Okay, the root vanishes. PA squared is 36, and if you square root, the length of the tangent would then, of course, be 6 units there. What a pleasure. Okay, I love the exam question linking to Pythagoras. Okay, so what I think it's for you to do is a bit of a practice example. Now have a look at this. This is really, really cool.